4 sites along their Neptune observatory. The observatory spans from the subduction zone all the way out to the spreading center at Endeavour, allowing longer scale observations of processes that are fairly poorly understood and also how they all work together. We're going to primarily assist the cable ship Wave Venture with some cable deployments and recoveries and repairs. And then we'll also be conducting some secondary science objectives. So we'll be sampling and also deploying Wally, the benthic crawler. We'll do some exploratory science while the Wave Venture is splicing cable on the ship. So sometimes we'll have about 20 or 30 hours, and we'll be able to go off and do some science. So we'll be doing a combination of sampling and visual surveys. So we'll probably be collecting a lot of push cores. We'll be working with the team to deploy some of the equipment that another ship will then come in later in the summer to deploy some seismometers. So we'll be prepping the site in place for the Sikuliak and Jason to come in later in the summer.
We're going to be working along the Cascadia margin, which is a large subduction zone where the Pacific plate is going beneath the North American plate. And so we're going to be looking at the seeps that are coming into the ocean. And also there's a lot of interesting biology associated with them because they're very similar to the hydrothermal vents. They have chemosynthetic ecosystems associated with them. Methane is becoming increasingly important to understand the inputs into the ocean because it's a very strong greenhouse gas. And we don't have a very good idea of the amount coming into the ocean. And we think that there may be some increases going on in the methane coming into the shallow ocean because the ocean is warming. And that actually changes the stability zone in which the methane is actually locked in an ice-like substance beneath the sediments. And that, if it gets into the atmosphere, then of course that's another thing we have to be concerned about in terms of a greenhouse gas.
So we are going from San Francisco down to Santa Barbara with 8 stops in between. Most of these are centered around submarine canyons to figure out kind of how the terrestrial and the marine worlds actually interact. And then there are a few other hotspots we're going to investigate along the way. We're looking for methane seeps, we're looking at a submerged volcano, and we're also looking at a few oxygen minimum zones, areas where life struggles to survive because there's a lack of oxygen in the water column. That is expected to get worse with global warming. So figuring out how marine microbes and animals are dealing with that now could be a glimpse into the future. A lot of these dive sites that we're going after are in national marine sanctuaries, so you can't really manage what we don't know. So we're trying to get the baseline and understand how to approach these going forward.
The Channel Islands National Marine Sanctuary encompasses 1,470 square miles off the coast of central California. It's an essential habitat for many endangered species. It also provides incredible regions to look at shipwrecks and maritime heritage. So there's overlapping ocean currents, and so the 4 northern Channel Islands are San Miguel, Santa Rosa, Santa Cruz, and Anacapa. And at the far western section of the islands, you'll find all the cold water species. And once you move towards the east, towards Anacapa Island, you're going to get more species that you'll find further south in warmer waters. So there's going to be 2 essential segments to the Nautilus cruise around the Channel Islands. First, we're going to be mapping and characterizing the seafloor. Once we have done that, we're going to go back with the ROV and do some visual characterization of what we find and what we pick up on with the multi-beam data.
So we're going to explore the area offshore Los Angeles, San Diego, way offshore out to about 200 miles. And it's a very unusual area for being near a continent because instead of being relatively flat and shallow, there are actually a lot of deep basins, a lot of very shallow ridges, some of them emerging as islands. And the reason is that there's a lot of plate tectonic motion still there happening. So there's a lot of deformation. So in terms of geology, it's quite fascinating. But it's also fascinating in terms of ocean circulations because it's very rough underwater topography kind of affects oceanic currents. And in turn, this topography and these ocean currents affect life, and we don't know how. Surprisingly, for being relatively close to Los Angeles and San Diego, it's relatively unexplored.
Our cruise will be exploring newly expanded areas of the Greater Farallones National Marine Sanctuary, and we'll be looking at not only mapping, but we'll be exploring shipwrecks. We'll also be looking for areas that we've never gone to before for some deep sea corals and sponges.
One of the targets we're going to look at is the USS Independence, an aircraft carrier fabled for its World War II service, but more famous because in 1946 it was selected as a target with close to 100 other ships for the first test of the atomic bomb. Basically, our plan is to use the ROV Hercules and learn more just through simple observation, but we're also hoping to do some detailed mapping to give us an overall sense of what Independence looks like, not through a sonar image, but in this case through detailed photographic measured mapping. Thanks to telepresence, thanks to the fact that Nautilus is going to be linked to shore, not only those of us on the ship, but scientists as well as the public are going to be there to participate in the dive, to add their own observations and to learn. And in that, make this something that really speaks to the power of exploration in the 21st century. It's for everyone.
The borderlands stretch from San Diego, California to Santa Monica, and it's a region that is densely populated in this Los Angeles region, but the seafloor right offshore is very poorly understood. Scientists know that it's probably very seismically active, that there are probably faults. Some seeps have been discovered that are related to these geological processes, and scientists expect that there are some really interesting biological communities. But we will go visit some of the sites that are